Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is out of boundary paths. And there is an m cross n grid with a ball. The ball is initially at the position start row and start column. You are allowed to move the ball to one of the four adjacent cells in the grid, possibly out of the grid, crossing the grid boundary. So we have to make the ball to cross over the boundaries of that grid. You can apply at most maximum max moves to the ball. So given the five integers m, n, move, max move, start row and start column, return the number of paths to move the ball out of grid boundary. So if the answer since the answer is very large, it should be returned as modular 10 power 9 plus 7. So this is a problem where we have to go through all the paths, all the possible directions, four directions with the maximum number of moves, such that the ball which is located initially is crossing the boundary of that grid. So we have to return all the number of paths. So for this, since we have to go through all the possible directions, we can write a max paths recursive function. This is going to return me the maximum number of paths. So max paths, where I will pass the start row and the start column and m and n, and I will also pass the max moves. So this function is going to be a recursive function. We will see what are the cases that we have to handle. So this is going to return me a max paths in an integer variable answer. And first it is we have to the start row. I will name it as row and start column as col, and the total number of rows and total number of columns and maximum number of moves, max moves. I will say it as max moves left. I will say max moves left. So what we have to say whether the ball is moved out of boundary. So we have to we have to check whether the row and column is out of the boundary case. I will write a small function which is going to say whether the row and column is inside the boundary or outside the boundary. Uh, I will write this as is valid. This is going to return me a bool value. So boolean value, if a boolean is valid of int row, int col, and int m and int n, the number of rows and calls, we have to return true only if my row is greater than or equal to 0 and my row is less than m and my call is greater than or equal to 0 and my call is less than the total columns. If this is going to return me true, it is valid, but for question itself it should be it states that should be out of boundary. So if it is not valid, I will making it as not, so it becomes true and it comes inside the if condition. And if this is a boundary case, row or call is out of boundary, if it is this case, what we have to check is we have to check whether the max moves left is 0 or not. If my max moves left is greater than or equal to 0, if my I will copy this. If my max moves left is greater than or equal to 0, then I can say that I will return 1. That is, I found a one possible path, or else I will return 0. So this will be my base case. And another case where I can say is if my max moves left is 0, then I cannot go further. Then I cannot move the ball further. So I will return 0 as well. Then I have four possible directions. I will declare a static directions array for 2, which I have teached yesterday. I will go through all the possible directions. This is -1 0. It is up direction. It is up direction. Then 1 0, this is down direction, and 0 -1, this is left direction, and 0 plus 1, this is right direction. I will declare a variable int paths, which is 0 initially. and finally at the end of the day I will return the paths. So I will go through all the possible directions. Int k is 0, k is less than 4, and k plus plus. If I will calculate my current row and current column, int x is equal to row plus directions of k0, and similarly in y is nothing but my call plus directions of k1. So now I have to calculate the path. Path is equal to paths plus max path function should be called, and where row and call is nothing but the x and y in our next recursive call, and m and n are the maximum rows and columns left, and the max moves left minus 1. I am taking this one path, so I have taken one move, so I should reduce my max moves left to minus 1. So it will be our code. So this is a recursive function, so it is going for all possible directions, 4 directions, so it may cost 4 power m into n. So the time complexity for this recursive solution, the time complexity for this recursive solution is 4 power order of 4 power m into n. So this is very big time complexity, and it will not be acceptable at all. So we have to do some optimization so that we can go for memoization technique. If we use a memoization technique, m into n, even we can consider the most left, but as for now we can consider the most left as, or else we can say into m into n plus into moves left as well. So that much number of moves we are going to take. So what will be the time complexity for memoization? Let us analyze, and we will convert the problem into memoization first. Before going into the memoization, there is a case that if the answer is very large, we have to return modulo 10 power 9 plus 7. So first we will declare a const int mod, which is 1 e9 plus 7. So this will be my mod value. So I will take a mod for every time, and I will finally return mod value, paths mod, that value. So finally we are going to return the mod value. So we can run our recursive code and see whether it is getting accepted for our sample test cases. Static int directions. It got accepted. We will use the example test cases as well. But this will definitely give TLE because of the time complexity only. So let us memorize it. So to do memorization, what is the technique? We have to see the changing parameters. The changing parameters is row, call, and this max moves left. So there are 3 parameters. So we will declare a 3-dimensional array. So we will say vector of vector int. It is a 3-dimensional array, 3-dimensional vector. I will name it as dp, and I will pass the I will define the size of the 3 dimensions, m plus n, vector of vector int n plus 1, and vector int, this is nothing but the max move plus 1. And initially I will declare everything to be minus 1, and I will pass the dp array, dp vector. And now what I have to do is I have to pass here the dp, and we have to pass the dp in this function as well. And what I have to do is we have to memorize it. We can memorize it by dp of row, call, and max moves left, max moves left. Superb. Now what we have to do is we have to check in the base condition as well. If my dp of row, call, and max moves left is already computed, if it is not minus 1, then I have to return that dp of row, call, max moves left itself. So we have done memoization, so we can run our code now. It got accepted, so we let us submit the code. It shows some DLE exit runtime error. Let us analyze what is the. It shows some integer overflow. Okay. So here we have to say integer overflow, right? So we will have we will add some brackets, and then we will calculate the mod. We will take this failing test case and we will try to run in our sample test cases. It got accepted, so now let us submit. So what will be the time complexity for this solution? For this solution we are memoizing it, so there will be 4 into, it is not 4 power, it will not grow exponentially, so 4 into m into n into the max moves left, so this will be a time complexity. It is much reduced, and the space complexity we are using a 3-dimensional vector, so which is m cross n cross and the max moves. So this will be our code for today's problem, and hope you like the solution. So let me know in comments. So let us submit the code once again, so that this time complexities will get submitted. So it got accepted. So hope you like this video. Let us see in tomorrow's LeetCode challenge. Until then, bye.